Hi everyone, welcome to my channel and continuing with the assembly of the Asuro robot kit. The manual does have some guidelines on the order of installation of the parts. So I think I'll just follow that. And they start off with the two dip sockets. And these are the sockets right here. So this accommodates a 28 pin dip, and this one here is for a 14 pin dip. And if you look at these, I mean, it wouldn't matter how you put the socket on the board, but the socket is sort of an extension of the artwork on the board with this notch, and the convention is that when you install the chip, when you orient the chip into the socket, that this notch here pointing, if you see the notch here, this pin here on the left would be pin 1. So that chip, you would make sure pin 1 would be inserted into the socket with that orientation. Let me bring you in closer here. I think you should be able to see the notch. There's the notch right at the top there on the 28 and also on the 14. And you just make sure that the orientation is the same as the artwork on the board there where it shows the notches. So since you have to solder these from the opposite side, I think I'll be able to tape these in place so I can quickly tack the pins. If I can get that in the socket, get those in the holes there. And here's the 14 pin. So just take some Scotch tape, secure these in place. So just flip this over and solder all those pins. So try to heat the pad and the pin and have the solder flow to the soldering tip. So put the solder on the opposite side. Want a nice shiny joint. See if we can get in closer there. That's about it. You don't want to leave the iron on too long because that is plastic and you could melt the socket. So let me finish up the rest of these pins and we'll start up again after I've finished. Okay, here's the last pin on the 14-pin socket. And that finishes up the soldering of those two dip sockets. See there? Look pretty shiny. I can remove the tape now. Next, it's recommended to attach K1 through K6, which are sensor switches, which there are 3 on this side and 3 on this side. See there, K1 through K6. 1, 2, 3, 4, 5, and 6. And it's important to have them flush on the PCB. Looks like these are those switches, and one on-off switch there. This is what they look like. They just sense whenever the front bumps into anything, presses in this switch. Gives you a reading that you've bumped into something on that side. So it looks like there's 2 contacts. It's just a switch, and then 2 hold downs sort of for the housing of this switch here. So these have to go in. If I flare these out a little bit, might be able to just help me hold them in. Yeah, those aren't going anywhere. So let me go ahead and solder these 6 switches on. Okay, so I have all these switches on now. You can see whenever this bumps into one of these, it presses in contact. Next, there's an 8 megahertz resonator. Let's see where that is. Here it is. It's got 3 leads on it. And that's the part. 8 megahertz resonator. Next, they suggest soldering in 8 diodes, D1 through D8. It's right here. It's a 1N 4148. Little glass diodes. And make sure you have the right polarity with the line indicating the cathode, and make sure you orient that so it matches the artwork, the line on the PCB. So you can see the line there facing on the top. That's right there. And it's good to have a nice set of needle nose pliers. We're going to have to put a bend in these so they fit in. Let's see how much extra is on each side here. So they fit like that. So put a little bend in. And fit it into the holes. So it's just like that. So the line on the diode matches the line on the artwork on the PCB. So I'll just hold that, flare these leads out to the side, and that holds the diode in place so I can solder, and then clip the leads off, the extra. Have these flush cut cutters. Just cut them off. And that's one diode down, 7 more to go. Now when you bend a lead on a component like a diode or a resistor, you don't want to bend it right where it joins the component, because you put stress and you might either crack the diode or crack the resistor internally, compromise its value. So you want to have a little strain relief, or a little, you want to be a little bit away from where the lead meets the component. So hopefully they've taken that into account on the hole placement on the PCB, but you want the bend to be away from the edge of the component there. You don't want it right at the junction of the component where it meets the lead. So that's what it should look like. So it should fit right in there now. So it practically falls in. I'm going to solder these all at the same time, so I'm just spreading out all the leads as I put all these diodes in place. Just more efficient that way. So now I can solder all these diodes without having to flip the board over each time to do an individual diode. Next component is D9, which is located right here. Make note of the polarity. Got the line on the diode aligned with the line on the artwork here on the PCB. Already bent the leads, so it just falls in place. Solder that in. And that's D9. And there's two jumper pins right next to it. So you want to insert the short leads right next to it right here. Don't put the jumper on yet. So I might have to just tape that down. And next there is a dual colored LED, and it has a polarity, so the shortest pin has to go through the hole that has the square pad on it right here. So that's the orientation for this dual colored LED. Shortest lead through the hole with the square pad. So these are the caps, and 1, 2, 3, 4. These have the number 104 on them, indicating 100 nanofarads. So we'll install those first. So these caps do not have polarity. So these are C2, 3, 4, and 5. So look for them on the board here. Is C2. That's right there. Okay, so I finished installing all these ceramic capacitors. Next, there are 8 transistors, and have to be careful here because 4 of them are NPN and 4 are PNP transistors. So I was looking at the schematic. You can see here there's 1, 3, and 5 and 7 are PNPs, and the 2, 4, and let's see, we've got the 2 and the 4, and the 6 and the 7 are NPNs. And on the parts list, it says here 1, 3, 5, and 7 are BC 327 or BC 328. So I have to figure out which ones are which here. Okay, so the 4 on this side are 3, 2, 7-4s. So these are T1, 3, 5, and 7. So I'll take these out and install these first. So T1, 3, 5, 7. Is T1 and 3, and on the opposite side is 5 and 7. So I have all the transistors installed, and next is a boatload of resistors. To start off with 10 1K resistors. So I have to install those. Are 1, 2, 3, 4, 5, 6, 7, 8, 19, and 21. I think I found a discrepancy. They have 21 here, but they do not mention 21 when they show the resistors here. They have, here they mention 19 and 24, but they don't mention 21. But I did locate it, and 21 is right here, along with 19. So this group of 1K resistors are 5%. So brown, black, red, and gold. And then there's a separate R24 1K, and it's a 1% resistor. So the resistors are going to be standing up vertically like this on the PCB. So this, for instance, is R21. And it will be like this. So I just about have all the discrete components installed. I have these two 220 microfarad 10 volt electrolytics I have to install, and the line here, it's also the shorter lead, points to the negative lead. And so these do have polarity. You have to make sure that you install them correctly. There's a plus right here, so put the longer lead into that hole. That's one. And here is C1, so it's C1 and C8 is the longer lead into the positive. And there's a second one. So those are two electrolytics. Solder those in place. So almost there. I just have these, I have some red LEDs I have to hook up, and also the so there's IR infrared diodes and the Phototransistors transistors in this packet here. So next we have IC2, which is the infrared receiver, and it lies flat with the dome pointing up. So we have to bend these leads at a 90-degree angle. It's ESD sensitive. Also, you don't want to apply heat to these leads for too long. You might damage the part. So it has to sit just about like that. So let me bend these leads. So it sits flat like this. So that's soldered in. Next we have the two phototransistors in the colorless case right here. This will be looking at the pattern on the gear with the alternating black and white. And here we have the infrared LED with the rosy colored case to it. And they have these little domes on them, these little bumps. So they go here and here, facing the gears. So we have T11 and T12 and D13 and D14 here. So this is what the infrared LED and the photo transistors look like that are facing the gear and that alternating pattern of black and white right there. So that's how they read that pattern. And this is the infrared LED installed. It has a flat on one side indicating the negative lead. And you line that up with the flat side on the artwork on the PCB. And the remaining two photo LEDs and the red LED go underneath. So I put the wheels on and I cut the ping pong ball in half, and I'm trying to gauge the length of these leads here for the last three components, because it just says that these components have to be placed at some distance from the PCB. So I've got the half of the ping pong ball under there, and these are the LEDs that are going to be able to allow this to follow a line. So I guess you want it as close to the line as possible without dragging. It has to be shorter than the ping pong, half of the ping pong ball distance. So I'm trying to gauge how long these leads need to be. Okay, we'll stop here. I've installed all the discrete electrical components except for the motors and the battery holder. I've cut the ping pong ball in half, and you can see here the LED and the phototransistors are just under the height of the ping pong ball. You want these as close to the table as possible if they're going to be trying to read a line. And in the next video I'll install the two motors and the battery holder and cross my fingers and turn it on and see what happens. But we can take a closer look here. You can see all the components. So you get an idea of the profile of the circuit board with all the components on it. And the only components underneath, again, are these, the one LED and the two phototransistors. So you just tie wrap the motors on and the battery holder, and have these switches here that detect when it bumps into anything. And here's underneath. Hopefully everything's been soldered correctly, right components in the right places, and hopefully all the solder joints are okay, making good contact. So this is the continuing Asuro kit project. If you found this video interesting, please like, subscribe, and or comment. And I'll see you next video where I'll be installing the two motors and the battery pack and turning it on with this switch right here. So thanks for watching.